Good morning students. Welcome to your data structure lab using C for third sem IT. In the previous session we have discussed about structure, union and pointer. In this video class I will discuss an important concept of data structure, that is stack. Stack is a linear data structure which work on LIFO principle, means last in first out. The element inserted last into the stack will be deleted first. So let us discuss it briefly about stack. A stack is a linear data structure that work on LIFO principle. LIFO means last in first out. Means the element inserted last into the stack will be deleted first. Stack has one end and that is known as top. We can insert in top and we can delete from the top. Whereas the queue has two ends known as rear and front. Stack contains only one pointer, top pointer, pointing to the topmost element of the stack. And in other words, a stack can be defined as the container in which insertion and deletion can be done from the one end known as top of the stack. And there are some important operations performed in the stack like push, pop, pick and empty. Push, add an item into the stack. Means inserting an item into the stack is known as push. And if the stack is full, we cannot insert, we cannot push into the stack, and the condition is known as overflow condition. Means when the stack is full, we call it overflow condition. Then pop. Pop means removes an item from the stack. Means removing an item from the stack is known as pop. The items are popped in the reverse order in which they are pushed. Means always the last element that is pushed will popped first. And if the stack is empty, if there is no element in the stack, we cannot pop any element or we cannot delete any element because the stack is empty, and the condition is known as underflow condition. So push means inserting an item to the stack and pop means deleting the item from the stack. And inserting and deleting, push and pop, will always done at top of the stack. Okay. Then pick or top. It returns the top element of the stack. Is empty returns true if the stack is empty, otherwise it returns false. So these are the operations performed in stack. Mainly the push and pop operation. Push means inserting an element and pop means deleting an element from the stack. Next is some key points related to stack. It is called as stack because it behaves like a real world stack, like stack of chair, stack of plates, piles of books, etc. A stack is an abstract data type with a predefined capacity, which means that it can store the element in a limited size or of limited size. It is a data structure that follows some order to insert and delete the element. Means it follows some order like LIFO, last in first out, or FILO, first in last out. Means the lastly inserted element will be first deleted. Okay. When we perform the delete operation on the stack, there is only one way for entry and exit as the other end is closed. Means the other end is closed. Only we can insert from to the top and we can delete from the top. There is one end to insert and one end to same end to delete. Means the way is one way we can insert into the stack, and from this top we can delete the element from the stack. It follows the LIFO principle. And the next is implementation. There are two ways to implement a stack. We can implement a stack using array or using linked list. And I have done the program using array. Okay, because it is easy to understand. First is push operation. As we know, push means inserting an element into the stack. Before inserting an element in a stack, we check whether the stack is full. Means we check the stack is full or not. If we are trying to insert element in a stack and the stack is full, then the condition is known as overflow condition. When we initialize a stack, we set the value of top as -1. Means if the stack is empty, then the top pointer is -1. Okay, the value of top is -1. To check that the stack is empty. Then when new element is pushed in a stack, first the value of top gets incremented, that is top equal to top plus 1. Means the value will be 0. The first element, the top will be 0. Okay. Then the element will be inserted only we reach the max size of the stack. Means when the maximum size of the stacks comes. Okay. And here is the figure. First the top is -1, means the stack is empty. After push 10 means we are inserting the value 10 to the stack. We are pushing the element 10 into the stack. Then top will be 0. Top will be 0. Then after that we are inserting another element, that is 20. Then top will be 1, means first is top 0, then plus 1, then top will be 1. Here the top is 2. Okay, and top is 3. So this way we can push the element. The next operation is pop operation. So before deleting the element from the stack, we check whether the stack is empty or not. If the stack is empty and we are trying to delete an element, then the condition is underflow. Means if there is no element in the stack, we cannot delete the element and the condition is known as underflow. And if the stack is not empty, we first access the element which point by the top. Means we access the topmost element of the stack. Once the pop operation is performed, the top is decremented by 1, means top equal to top minus 1, means it point to the next element of the top element. Okay, so for this example, view this figure. First, here the top is 3 and the top is pointing to the third, means the 40, the element 40. Then after that, here the value of top is 3 because 0, first element is 0, 1, 2, 3. Here top is 3 pointing to the element 40. So when the pop operation is performed, the 40 will pop out. Okay, and the top will be top minus 1, means top will be 2 and it will point to the 0, 1, 2, means 30, element number 30. Okay, again if it will perform the pop operation, then the 30 will be pop out and the top will be 1. Okay, so after that the pop operation will pop out the element 20 and the top will be 0, and the last element, that is the top, when the top is 0, it will pop out the element 10 and the top will be minus 1. Minus 1 means the stack is empty. After that we cannot delete any element from the stack. So this way we perform the push and pop operation. Okay. So let us write program for push and pop. So here the program. So first is int top equal to minus 1. So first time the top is minus 1, means top will be point to minus 1, means the stack has no element in it. And I have defined an array having size 4 and we have 3 operations: push, pop and show. Push will insert element into the stack, pop will delete element from the stack, and so is display element of the stack. After that int main, then int choice while 1. So there are many operations like first is push the element, number 2 is pop the element, number 3 is show, and number 4 is end. So there are 4 choices. So printf operation performed by stack, then printf 1 for push, 2 for pop, 3 for show, and 4 for end. It will show in a menu. And printf enter choices, enter choice, then scanf percentage choice, means choice will be in a numeric value and it will store in the int choice. And if the choice is 1, then we will perform the push operation, and if the choice is 2, then it will perform pop operation, and if the choice is 3, then it will display all the element of stack. Okay, 4 is end. So if the case is 1, it is push, if case is 2, it is pop. Okay, if case is 3, it will show, and if case is 4, then it will exist. Means these are the functions. If case is 1, it will call the push function. Then break. If case is 2, then it will call the pop function. Okay, and if case is 3, then it will call the show function. So on it will work as. Okay, then the push operation. So if it is choice is 1, it call the push operation, push function. So push function check if top equal to size minus 1. Okay, size minus 1 means if the size is 4 and top value is 3. Top value is 3 means it is full. Then it will display the condition printf overflow, means the stack is full. We cannot insert any element to the stack. Else otherwise it accept an element in x. Okay, and top will be top plus 1, and the array top means first time the top value is minus 1, minus 1 plus 1 it will 0, and array 0 will be the x, means in 0th element of array it will store the value of x. Okay, so this is the push operation. Every time the top will increase by 1 and it will store the value in the array. The next is pop operation. In pop operation it will check if the top value is minus 1, then it will display underflow condition. Okay, and if it is not minus 1, otherwise it pop out the element, means it will display the top element and top will point to the next, means top equal to top minus 1. So this is the pop operation. And in display it will check if the condition is minus 1, printf underflow means there is no element, we cannot display any element. Otherwise it start from top, I equal to top, I greater than equal to 0, I minus minus. Means from the top it will display up to 0, all the element of the array it will display. Okay, so the output is like this. It first of all it display operation performed by stack. There are 4 options, 1 for push, second for pop, third for show, and 4 for end. Okay, the user will enter any choice. Here the user enter choice number 1 means push operation. Enter element to be inserted to the stack, then the user insert 10. Okay, then the choice is 3, then the element present in the stack is 10, it will display the element 10. Okay, then again it is showing the menu, then the user choose 2 means pop out the element 10. Okay, then the lastly enter choice 3 means there is no element, it will show the message underflow. So this way we can do the push and pop operation of stack. Let us do in C. Do it in C. Let us click on Turbo C++. Click on Start Turbo C++. Okay. Open the stack program. I have written the program. So first of all, I have declared top equal to -1. First time the top will be -1 because the stack is empty. Then I have declared an array with size 4. Then the three function push, pop and show. And then I have displayed the menu for push the element, then pop the element and show and end. Then enter the choice, asking the user to enter the choice and accept it and store it in int choice. Then according to the choice, we have used here switch choice. Then case 1, if the case is 1, it will call the push operation. Okay. Push operation, then break. If the case is 2, means if the choice is 2, then it will call the pop operation, then break. If case is 3, it will call the show function, and if case is 4, then it will exit from the program. And other than 1, 2, 3, 4, if user enter any other choices, it will display the message invalid choice. Okay. Then the push operation. In push operation, first it will check if pop equal to size -1. In size, in this program I have written size is 4. I have defined it at 4. If the size is 4 minus 1 means 3. 3 means from top 0, 1, 2, 3 means it have 4 element in the stack. Then the stack is full. It will display the overflow condition. We cannot insert it into the stack. Otherwise, it will ask enter element to be inserted to the stack, and it accepts the element and store it in X. After that, top equal to top plus 1. First of all, here the top value is -1. -1 plus 1 means top equal to 0. Then int array top means array 0 equal to X, means at 0th element of array it will store the X value. Okay, so in this way it will enter the element in the stack by doing the top equal to top plus 1. Then the next function is pop function. Pop plus check if top equal to -1 means if there is no element in the stack, it will display the underflow condition. Okay, otherwise it pop the element, it will display the top element of the array, and the array will next point to the next element, means top equal to top -1. Okay, so in this way it performs the pop operation. Then void show. Void show, first it will check if the top equal to -1 means if there is no element, it will display underflow. Otherwise it display element present in the stack. First I value is top. Okay, then I greater than equal to 0, then -y. Means from top to up to 0th element it will display all the element using for loop. Okay, so by this way it will perform push, pop and show function. So let us compile it. Okay, then run it. So it will showing the option 1 for push, 2 for pop, 3 for show and 4 for end. So I am giving here the choice number 1. Enter element to be inserted to the stack, that is 11. Okay. Again I am inserting the choice number 1. Then I am inserting 22. Okay. Then I will choice number, enter the choice, that is 3. Means it will display the element of stack. Okay. The element present is 11 and 22. 22 is the last element. And if I want to pop out, means choice number 2. So it pop out the upper element, that is 22. Now I want to display the element of stack, that is only 11. Okay, so this way we can perform push and pop operation of the stack. Okay, so in this way you have to write the program in your record. You have to write all the definition and key point, all the points that I have discussed in it, and you have to draw this diagram in the white page, and you have to write the program with its output. So this is all about your stack. So next class I will discuss about queue. Thank you.